In this lesson, we're going to be dividing polynomials and learning about the remainder and factor theorems. So we're going to be showing you long division with polynomials, but then we're going to switch over to what's called synthetic division, and you're going to see that that's a lot simpler or easier to use than the long division. So let's review over long division, which you learned way back in elementary. So let's say we had 6 divided by 2. So we're going to do long division, so 6 divided by 2, 2 is the divisor. What times 2 is 6, which is 3. 3 times 2 is 6. Subtract those, you get a 0. So the remainder is 0 on there. So that means that 3 and 2 are factors of 6. So 2 times 3 does equal 6, so those are factors of 6. And let's try one more that has a remainder. Let's say we had 7 divided by 2. So long division, we have 7 divided by 2. So what times 2 would give me 7? Well, there isn't anything, but the closest thing would be 3. So that's 6. Subtract those 1, so we have a remainder of 1. So we can write that as that way, or we can write it as 3, 1 over your divisor. So that means that 3 times 2 does not equal 7, but we'd have to add 1 in order for that to equal 7. And this is the form we're going to be writing it in eventually. So we're going to have factor times a factor plus the remainder if there is a remainder in there. So here's our first problem that we're going to do dividing two polynomials. And we're going to use long division on this. And you can see from our divisor over here that the coefficient on the x term is a 1. That is a 1, and it has to be a 1. If it was not a 1, then we'd have to divide by everything by whatever that number is. But since it's 1, we can just use that. So we're going to write it as 6x cubed minus 19x squared plus x plus 6 divided by x minus 3. Alright, for the first step then, we're going to just bring down the 6x cubed. And we're going to find out what times x, so we're going to look at this, the x in this term right here where I just circled. What times x would give me a 6x cubed? Well, that would be 6x squared. So 6x squared times x, so we multiply these two together, gives me 6x cubed. We subtract those and get 0. So now we take the negative 3 in that times the 6x squared, and that's going to give us then negative 18x squared on there. And now we are going to subtract these. So negative 19x squared minus negative 18x squared is negative 1x squared. Now I go back to the x in the x minus 3. What times x gives me negative 1x squared? Well, that's going to be then negative 1x, because negative 1x times x is negative 1x squared. Subtract those, and we get 0. We are now going to bring down the x here, and we take the negative 3 times the negative 1x at the very top, and that gives us 3x. Subtract those. Oops, I'm sorry, that should be a negative 3, so that should be a minus 3 right there. And when we add those, then we get negative 2x, bring down the 6, and once again we take what times x would give me negative 2x, that'd be negative 2, and so we put negative 2x, and then we have negative 3 times the negative 2 at top, which could be positive 6, subtract those, and we get a remainder of 0. So that means that those are a factor of my original equation. So that means 6x squared minus 1x minus 2 times x minus 3. So both of those are factors of my original problem because there's no remainder. If there was a remainder, you'll see in a minute, then they would not be factors. Just like on the other page with the 7 where there's a remainder of 1, that was not a factor because we had to add 1. So those were not factors of 7, the 3 and 2. But since we don't have a remainder on this one, those are factors. Now we're going to use synthetic division, so we're going to take our original problem, and the problem has to be written in descending order from the highest exponent down to the lowest. So you have x cubed, x squared, x to the first, and then x to 0. We're only going to list the coefficients, so we're only listing the 6, the negative 19, the 1, and the 6, and then we're only going to be using the 3. Now if this was a plus 3, then we'd be using negative 3 in our problem, but since it's minus 3, we just use the 3. Alright, so I set it up there. I only use the coefficients, and you can see I set it up a little bit different. And also in this one, we're going to be adding our terms instead of subtracting like in long division. So the first thing I do, I just bring down the 6. I don't do anything really with it. I just bring it down. But now I take the 3 times the 6, and that gives me 18. Add those together, I get negative 1. Take the 3 times the negative 1, get negative 3. Add those together, get negative 2. And the 3 times the negative 2, which gives me negative 6. Add those together, and that gives me 0. The last term is always going to be your remainder, so I'm going to put a line there. That just represents my remainder. So you can see my remainder is 0, just like on the previous page, it was also 0 there. So now I'm going to write my answer in polynomial form, and it always starts with the exponent, one less than the exponent of the original problem. So my exponent of the original problem was x cubed, so this is going to start with x squared. So I have 6x squared minus 1x minus 2. So that is my answer, and since, once again, I don't have a remainder, that is a factor. So that means x minus 3 times 6x squared minus 1x minus 2. Those are factors of the original polynomial. So if I would multiply those two together, I'd get my original answer. And you can see I multiplied those out, and I did get that answer. Alright, so now we're going to do the remainder theorem. And I've already kind of stated if we have a remainder, then it's not a factor. If we do have a remainder, then it is a factor. So now it's written as a function form. We're going to multiply these two. This is also called synthetic substitution. So we're going to use synthetic division, just like I did on the previous page. So we're only going to use the coefficients, and then the last term in the x minus 2, which would just be the 2. So my polynomial is in descending order, so it goes x to the fourth, x to the cubed. You see I don't have an x squared, so that's this x squared right here where it would go. That's where this 0 comes in here, because I have to have the x to the fourth, x to the third, x squared, x to the first, and then x to 0. So that's where all those are going to come into play. That's why I have a 0 in there. So I bring down the 3, and then I take 2 times 3, which is 6. And once again, I'm going to use addition, so that would give me 5. 2 times 5 is 10. 0 plus 10 is 10. 2 times 10 is 20. 20 plus 2 is 22. And 2 times 22 is going to give me 44. Alright, and negative 6 plus 44 is then 38. And that is my remainder. That's the last term. So you start with one less of the exponents, so there's 4. So in the original, so now I start with one less than that, so I'd have 3x cubed plus 5x squared plus 10x plus 22, and my remainder is going to be 38, so that's 38, and you put that over your divisor, which is the x minus 2. Since I have a remainder, then this answer that I'm putting a square around is not a factor of my original polynomial. So nothing times that would give me my original polynomial. So you can see in my red box down there, my original is in the blue, and my answer, what I found out, times the x minus 2 plus the 38 is what I'd have to do in order for that to equal my original polynomial. So if you remember clear back from the beginning where I had 2 times 3 plus 1 equals 7, that's the form I was talking about. A factor times a factor plus the remainder would have to give me that. Alright, now we're going to do the factor theorem, and if we're given one factor, then we need to find the other factors that would, when we multiply them together, would give me my answer. So like I was given in the 2 times 3 is 6, one of the factors was 2. I had to find the other factor, which was 3, and so now 2 times 3 is 6 then. So I'm given a polynomial function there. It's x cubed plus 5x squared minus 12x minus 36. And we want to see if, well, we know that x minus 3 is a factor. So we want to know what did we multiply x minus 3 by in order to get our polynomial function, that original equation. Alright, so we know that one of the factors is x minus 3. So if we'd graph that, and you remember from 8-1, that's what the graph would look like, that one of the factors, or one of the zeros, is 3. So that means it crosses the x-axis at 3. So we have to find those other 2 points. So we have to find this one and this one. I'm hoping that's where they're at because I just drew that freehand, but I know one of them is 3. I need to find the other 2. So once again, I'm going to use synthetic division. So bring down that 1. And then 3 times 1 is 3. And once again, we're going to be adding these, and that's 8. 8 times 3 is 24. Add those together, we get 12. And 3 times 12 is 36. Add those together, and we get 0. And since it's our last term there, that means that is our remainder. In the green, 1, 5, negative 12, negative 36, I didn't have to put any zeros because my exponents on my variables were 3, 2, 1, 0. So they went right in order. I wasn't missing any, so that's why I didn't have to put any zeros. Now, to write my answer, then, I always start with one exponent less than what the original had. So the original had x cubed, so I'm going to start with 1 less than that. So it'd be 1x squared, or just x squared, plus 8x plus 12. They're all positive. If they would have been negatives, it would have negative 0. But then I have a remainder of 0. So that means that x minus 3 times x squared plus 8x plus 12 are factors of my original problem, original polynomial. So if I would multiply those together, I would get my original. But I can also see that this can be factored into x plus 6 and x plus 2. So really I have these 3 factors then. So if I'd multiply all these 3 together right there, I'd get my original polynomial function there. So I'd FOIL them and then distribute the other ones. So if I'd multiply them all together, by distributing and FOILing, I would get my original problem. So if I want to see where those would graph at, where my zeros are, zeros mean they cross the x-axis at that point, I'd set each one of these to 0. So I'd have x minus 3 equals 0, x plus 6 equals 0, and x plus 2 equals 0. And then I'd add 3 to both sides, so I'd have x equals 3. Subtract 6, so I'd have x equals negative 6. Subtract 2, so I'd have x equals negative 2. So if I graph that then, make sure that shows up, then they would have at 3 would be a point, at negative 2 would be a point, and at 6 would be a point. So then it's going to go something like I said, like that then. So that would be my zeros. Those points are zeros, and which makes it 0. When I put those numbers in my original function, polynomial, I would get 0 as an answer, which makes sense because I'm on the x-axis, which means my y-coordinate is 0. And you have to refer back to slide 5 because I forgot something with the remainder theorem. So I'm taking that problem. This is called direct substitution. So I can take this term right here and call that f at 2. And I'm just going to substitute that 2 in for all of my x's in my polynomial, just like we did in 8-1. If I get a number, then that means that that's my remainder, which means on slide 5 that my factors are not, those answers are not factors of my original. So if I get a number other than 0, then it's not going to be a factor. So I substituted 2 in for x, and now I'm going to solve it. So you can see my work there, and since I got a number or an answer of 38, that means that is my remainder. So go back to slide 5, and you'll see that that was my remainder. And since I did get an answer other than 0, then that means I would not have any factors of, when I do my division, of that polynomial. So that is a lesson, and good luck to you, and if you have any questions, let me know. Bam!